Metaverse is a concept still rather hard to define, but which is said will significantly impact our lives in the near future. If it was only our private life, then it wouldn't be worth doing a presentation about it in a biology conference. But currently the metaverse is advertised as the next mobile internet where virtual socializing is going to be just as smooth as in reality, and that includes your working and learning activities. So the trend suggests that metaverses will impact our work life as much as our private life. And we will be doing our job by switching from one integrated workspace to another thanks to extended reality devices. Integration is the key concept here. People in the science community would rather talk about pipeline or platform, but really it's the same thing. It's the possibility to do a set of tasks from start to finish using only one tool. For a state-of-the-art example of such integrated workspace, I advise interested viewers to watch the recent talk given by Steve Horton and Jan Verster during the last NVIDIA GTC 2022. So what's it going to be like for us biologists? How is it going to affect the way we do our work? What will the metaverse of biology research look like? We designed ECellDive exactly with those questions in mind. It's an example of an integrated workspace that we may find in the metaverse of biology tomorrow, but with the tools of today. It's about visualizing biological systems in virtual reality to help you simulate and model them in real time with your colleagues. We chose VR as our entry point in the metaverse because the technology is arguably more stable than augmented or mixed reality. Within all the VR devices on the market, we use the MetaQuest 2, formerly known as Oculus Quest 2, because it's autonomous, easy to set up, and comparatively cheaper. ECellDive itself was developed using the game engine Unity. Although originally used for games only, Unity has greatly diversified its targets. Now, let's focus on the first part of our key sentence for the project. ECellDive is about visualizing biological systems in VR. The setting of ECellDive is pretty simple. When you launch the application, you're dropped in a virtual environment that we call a dive scene. There, you can establish a connection with a remote server to do a set of actions like importing data, requesting calculations, and saving results. Once data is loaded in the dive scene, it is embodied by a 3D model. To actually visualize its content, we can dive into it, which effectively transports us to another dive scene. To our knowledge, virtual reality applications already developed for research purposes mainly emphasize visualization. Although it's one main selling point for entertainment VR, we believe it cannot be the same for professional VR. Because in a professional setting, you expect tools to help you do your work, not just something that will keep triggering wow moments. And that will certainly hold true in any metaverse in the future because of the need for integration that we discussed previously. That's why we developed ECellDive with the idea that visualization is not the goal itself. We want the application to be an integrated workspace for visualization, modeling, and simulation. Hence, the second part of the key sentence for the project. For a demonstration of simulation and modeling in ECellDive, we reproduce the Escher FBA web application. If I quote, Escher FBA is an interactive pathway visualization tool for on-the-fly flux balance analysis calculations. Credits for this work goes to Elliot Rowe and his co-authors. Please check out their paper if you're interested. Before doing a flux balance analysis, we used a group by module in ECellDive to colorize edges according to subsystems. That way it's much easier to recognize famous parts of this metabolic pathway. In pink, it's everything related to outer and inner membrane transport. In yellow, you have the glycolysis. In green, it's the pentose phosphate pathway. In dark blue, it's reactions related to pyruvate. And in red, you have the citric acid cycle. We'll just ignore the rest for this demonstration. With this done, we connect to the server and ask it to perform a flux balance analysis. After a few seconds, we can clearly see the fluxes as the reaction edges are scaled accordingly. We see that, as already supported by biological knowledge, significant fluxes go through the citric acid cycle and the glycolysis. So, it's nice. We simulated the fluxes, but we also said we wanted to do modeling. For this purpose, users can very easily knock out reactions of the model and see how this impacts the fluxes. Let's try knocking out the glycerol 3-phosphate dehydrogenase, which currently has an important role in the metabolism. After asking the server to recompute the FBA, the fluxes have completely changed. Now they mainly go through the pentose phosphate pathway, and it became the main source of internal production of pyruvate. The other sources in pink corresponding to importation through the membrane. Up until now in this demonstration, there was only one user working alone. But it's not very realistic of a work environment in the metaverse, right? And even if you leave the metaverse out of the picture, researchers seldom work alone. particularly in an experimental science such as biology. Therefore, we believe it's mandatory for any professional VR application to offer extensive support for real-time collaboration as well as long-term data sharing. And that's why we included this aspect in ECellDive. For real-time collaboration, several users can connect in a host-client architecture on a local area network. One user will create a session, and the others will join him. Once all users are together, anybody can import data and dive into it. That way it's possible for the users to discuss directly about the simulation results and the modeling. Regarding long-term data sharing, we're also working on the format of modification file, which can let people safely keep track of who did what to a model. This ensures safe collaboration on the long term, and even if the main author of the model is not connected to supervise a work session, he can still review what happened later on. ECellDive is a virtual reality application helping us figuring out how we can do research in systems biology in the incoming context of the metaverses. Please be aware that this project is still considered in alpha stage and expected to change. Nevertheless, the code of the project and its releases are publicly available on GitHub. The documentation is quite scarce at the moment, but we welcome any interested tester or potential collaborator. Critics, feedback, or suggestions are also, of course, very welcomed. Thank you very much for watching this video. I hope you enjoyed it and that you're having a meaningful time at ISMB 2022. See you around for more discussions.